All right, now we're going to talk about the type of matrix multiplication that takes a little bit more time and energy to complete, and that's when we take one matrix and multiply it by another matrix. And one of the qualifiers before we multiply any two matrices, it's important that we find that the number of rows in the first I want to make sure I say this right. The columns in the first matrix need to be the same as the number of rows in the second matrix. So the number of columns in the first matrix have to be the same as the number of rows in the second matrix. And I'll show you what I mean by that in this example. So, for instance, in matrix A, the number of rows are, or the number of columns are 1, 2, 3. 1, 2, 3. And the number of rows in matrix B are 1, 2, 3. So it's important that the columns and the rows match up. And the easy way to remember this is, so this is a 2 by 3 matrix, and B is a 3 by 2 matrix. Just think about when you put them next to each other, you want the last and the first to be the same. So in this case, that's true. 3 and 3, so we're good. We can multiply A times B. So the first thing we do is we check to make sure that the columns and the rows are, that they match up. And then the second thing we do is we decide what the size of our answer is. So let me write this down. So the first thing is check for columns, rows. And then the second thing is we decide on the size of solution matrix. And the way that I decide on the size of my solution matrix is using the other two numbers, the number of rows in the first matrix and the number of columns in the second. So the inside numbers tell us if these two matrices can be multiplied. The outside numbers tell us what the size of the answer is going to be, which is that the answer here is going to be a 2 by 2 matrix. So let me write all this out the way that I would if I was solving this on a piece of paper. First thing I do is I would say A times B. Let's write all these numbers out next to each other to make the multiplication easier. And so I'm just copying A, and then I'm copying B. And then, hold on, last column. And then I'm going to write the size of the solution matrix. And the reason I do that is I know that this is going to be a 2 by 2 matrix because I'm using the leftover numbers, the outside numbers of our dimensions. So this number and this number. That's how I know what the size is going to be, 2 by 2. The reason that I kind of draw the solution matrix out before I find the answer is I know that I'm done with my math work once I have 1, 2, 3, 4 numbers plugged into this solution matrix. Once those 4 numbers are there, then I can say, check, I am done multiplying these matrices. All right, so now how do I actually find those numbers? This is the tricky part. So the first thing I'm going to do, remember it's rows and columns, rows and columns. So first thing I'm going to do is the first row of the first matrix is going to get combined, whoops, scrolling when I don't mean to, is going to be combined with the column, the first column of the second matrix. So first row, first column. And here's how I combine them. I say the first number times the first number plus the second number times the second number plus the third number times the third number. So kind of a mouthful, but we'll write it out. So it's 2 times -1 is -2. And then I add it to the second pair. 3 times 0, that's 0. And then the last pair is -7 times 5 is -35. All right, If I take those numbers, -2, 0, and -35, and I combine them together, that just is -37. So this first position is actually -37. So actually, I'm going to have two solution matrices. One with the long answer and one with the shorter answer. Okay, so that's the first place is calculated. All right, let's find the second position. So we found the first column, first row. That's what this is, right? 1, 1, first column, first row, by taking the first row and the first column of each of the two matrices. So now when I want to find row 1, column 2, I take, let's use a different color. I'll do green. We're going to use row 1 and column 2. And I'm going to combine it in the same way. I'm going to make pairs and add them together. Multiply and then add. 2 times 8 is 16. 3 times 2 is 6, so I add that. It's an addition sign. And the last pair is -7 times -3, which is +21. When I add those together, 16 and 6 would be 22, plus 21 would be 43. We'll choose another color. All right, so we have the second position done. That was row 1, column 2. Now I'm going to move to the next position, which is row 2, column 1. So now I go to the second row, row 2, and I'm going to combine it with the numbers from column 1. Hopefully you're seeing the pattern here. Combine 1 and 1, 2 and 2, 3 and 3. So 1 times -1 is -1. -4 times 0 is just 0. And then 5 times 5 is 25. When I add all of those together, I get 24. -1 and 25 is 24. So I have second row, first column. Now last but not least, I have the second row, second column. That means I'm going to use the second row and the second column. I'm going to make pairs and add them together. So 1 times 8 is 8. Second pair is -4 times 2 is -8. So I'll put -8. And then the final pair is 5 times -3, which is -15. So I have 8 minus 8 is 0. Minus 15 is -15. So my last number is -15. And that is my answer. So I took a 2 by 3 matrix, multiplied it by a 3 by 2 matrix. I can do that because I have the same number of columns and rows. Now that's important because of course we're making pairs of the columns and rows, or the rows and the columns. So this worked because the inside numbers here are the same. Our solution matrix is, we find that by using the outside numbers. It's a 2 by 2 matrix. And then I went through and row and column, row and column, row and column, row and column. I did it 4 times, making those pairs. I was able to get each of the numbers. And this final matrix here is my solution.